for this week, we'll be talking about data visualization. It's basically having data and visualizing it in a way that it's easier for us to do decision making, right? And us to get a quick glance and overview on what's the data all about, right? So it is basically a transformation that transform the raw data, right? The data that we get from sensors, right? The data that we pull information from, let's say, a stock exchange or financial reports or medical data, social media data, into a visual context of information, right? When we picture the data in an interactive way, we can slice and we can do some dicing, right? We can basically see it in a different angle as well, right? So it provides a means to explore and interpret data such as pattern, trends, and color correlations, right? We can also do this through mathematical equations and just using plus minus symbol in which dependent variable is affecting the independent variable affecting dependent variable and so on and so forth. But that's very math heavy and it's not consumable for everyone, right? So, successful data visualization presents easiness of understanding the data at the next level. That's what it's trying to solve. Okay, so it also presents easiness of reading and insights of raw data as well. Okay, so here's an example. Very relevant, right? Let's say the COVID-19 data visualization, right? So we can grab a lot of like data points from, let's say, every day, right? As you can see in the left hand side, right? And then let's say in each file you do have like the province, country, and last update, how many confirmed cases, deaths, and recovered, and so on and so forth, right? And once we basically feed this in a data visualization application, right, we can essentially create something like this with what we call like a heat map, right? Or actually heat map with also like bubbles, right? Bubble chart. In this case, what helps us is now we in a quick glance, right? We see the map of many continents and countries, and we see the intensity of the circle, meaning the bigger the circle, it already gives us an idea that there's more cases, right? Or total confirmed cases, right? And you can see that on the right hand side, you could also have the total deaths and total recovered, right? Which I think when you click, you can toggle, you'll see it in a different way, right? And that's one of the ways to use data visualization right away. And this one is, right, the next one is another total confirmed, right? And now this one is focusing on the United States of America, the cities and states. Okay. So to do this, there's many ways. Well, we can use Power BI by Microsoft, Tableau, right, or R. And another route is using Python as a very general purpose programming language, right? And one of the data visualization package is called Matplotlib, right? It is the most popular for 2D, 3D plotting, and it's already been there for more than 10 years. And you can do bar charts, histogram, power spectra, templates, scatter plots, and so on and so forth, right? There are many low-level controls of plotting figures as well, right? And you can check out the website with matplotlib.org to know more about it, right? Okay, so we have this bouquet, right? It's a web-based toolkit for data visualization with interactive functionalities, right? It has many options for graphical representation of data and efficient on large or streaming data set. So this is another package. Okay. There's this other package called Seaborn, which is also a web-based toolkit for data visualization. It can basically beautify, meaning make it more pretty or make it more easier for us to understand, or a good interface with Matplotlib, right? So it is used for more statistical graphics, right? And works with PyData, NumPy, and Pandas, which are all other packages in Python. Plotly, same again. So it's another package. It's unique set of plots such as contour plots, 3D charts, in addition to 2D plots, right? And also provides subplot features. So this one is really a good chart to show the life expectancy. Okay, and if we also animate this in such a way that in every year the life expectancy changes, it will be very great to see. And life expectancy, data visualization, and you should be able to check this if you just Google. Okay, I'll show you this video and not play it. Okay, so if you search for Hans Rosling 200 countries, 200 years, it will be so fascinating to see the power of data visualization, right? Moving from one to another. So I can just skip it, right? And you guys can go ahead and check this video. So that is very powerful storytelling through data visualization, right? All right, so we'll head back. This one, okay. And next to install, we do pip install and the following packages. So anatomy of a figure. So you have to learn all of these different components when you do a visualization, right? You've been seeing some of this when you are basically doing a simple bar chart or pie chart, right? You always have the title of the chart. You have the legend, right? And I did not know why did it go there. So there's the line, there's the grid of the chart, there are markers of the scatter plots. These are data points. You have the name for the y-axis, right? You have the name for the x-axis. You have your major and minor ticks, and also figures. Okay. So next, we do have this. If you install Matplotlib, you can easily create, let's say, a simple line, right? You can plot a line graph. So as a standard way, you import, right? And this is just an alias so that you can just use PLT. You do want to, let's say, initialize a variable with a list of integers, right? And then you want to use the Seaborn package and initialize and create a subplots, right? And assign that to fig and x. And x, you want to plot, let's say, the input values in square, and provide the thickness of the line so it becomes thicker with more numbers, the higher the number. And you can set the title, the labels, and also the text. So titles, labels, and the text. And then show so that it renders. And you can do that again using now a scatter, right? Instead of line, and you would get something like this. Pretty easy, right? Next, you can have, let's say, this type of range, right? From 1 to 1001, and this one is just a list comprehension. It means that for every x in x underscore values, so from 1 to 1001, we want to basically raise that to 3, right? And then we want to use the Seaborn again and initialize a subplot and use a scatter plot, and now use the blue and have a low to high, white to light blue to blue, and we'll now see something like this, right? Okay. So you can also have a Jupyter notebook as your integrated development environment, right? You can use it as a plugin in your VS Code, and just do the following. right? And then you can also install it directly, right? By going to jupyter.org right away as an IDE. Sorry, this one is as a plugin, right? This is as a um, standalone and web-based IDE. So here's PlantSnap. It's basically a free plant identifier app, right? So this is image recognition, right? So this is one of the first exercises people usually use for image recognition, right? You basically need to download a data set of different flowers, and you basically input that data, and you basically define the attributes that it has, right? And now you run it. And to do that, you just need to basically use pandas, right? And you want to load your data set and define those attributes. And then you want to print it to dot head, and now you'll see something like this, right? And checks whether it's the what flower it is. Okay, so if we do now want to do a plot on like different flowers and of their different sepal width and sepal length, you can just load that in your matplotlib, right, and create a subplot and do a scatter plot and have a marker. You can change the marker and the color as well. And then here's another one where you add more different colors. Look, so this is way better. Now you can associate which is for which flower, right? And you can also use a line graph, right? And also histograms. So you can just follow along the code to check it out. And always a good question, which is the best way to visualize a certain data set? Some would work, some would not. And these are the references. So if you do have any questions, do ping me in the chat or email me in Outlook. Thank you, and see you next week.